Hello and welcome, my name is Nilaus, so this is the second installment of the tutorial for Angel's Mod's petrochemicals. In the very first episode we were looking at something quite basic, the actual creation of oil and gas and how to split that and crack it. If you haven't seen it, please go back and have a look. What we're going to do now is that we are going to look into residual and synthesis gases. Those are some strange components that do not exist in a vanilla game, so I feel that it was warranted to take a look at it. We noticed in the previous episode that we might just as well go up there just to have a glance. We noticed that there is, from the normal oil refinery, there is a residual here, oil residuals, solid form. Well, I also briefly showed you what can be done with these, and they were made into residuals. So let's have a look at this little machine here and walk through it. Basically, this one takes the oil residuals, places them into the steam cracker. The steam cracker will then make residual gas. This is also what we saw last time, and it will be put into this container here. Additionally, we just taking the purified water barrels out and getting in here. So once we have the residual gas, that is sometimes used, very rarely. For example, for lubricant, it is used, combine it with mineral oil and you have lubricant. However, in most cases, residual gas is, as it says, residual. And the best use of it is actually to transform it into a more high value component called synthesis gas. You can actually see here that you take 10 residual gas and add some water. Water is free, so you actually get 10 residuals into 15 synthesis gas. The synthesis gas is quite valuable, so you can see here now we're starting to generate it, and this is where the focus will be on this episode. Now we have a way to convert our oil residuals, which are garbage, on a one-to-one into residual gas, which is not particularly useful, a bit, but actually the most valuable way is to transform it into synthesis gas, because that has a lot of different values. Now let's have a look at what we are doing here. I can see something is missing. No, we'll do that. Okay, here we have basically a traffic light. In here we have water. That's always nice to have some water. We have the fuel oil, the naphtha, and the base mineral oil. Those are all coming from the very basic form of the oil refinery. Let's again have a glance up here. The output here. Now we covered the oil residuals, what we can do with these. In the previous episode we were just basically taking these three components and putting them into barrels. Now one use of them, this is not the only use, but one use of them is to convert them into synthesis gas. This is what we're doing here, and let's start out by activating this machine. What happens is, for example, on this one, we take the naphtha. The naphtha goes in to this machine, and then it becomes, again, a steam cracking. You get 10 naphtha, becomes 15 synthesis gas. So again, this is quite a valuable way of converting it. In the other cases, it is a 10 to 10, and in the last cases, it is a 10 to 10. However, the important part is actually that all of these have a waste residual gas, and that's easy to cover because you just take the residual gas down here, pipe it back in, you have the water available, and bring it back in as synthesis gas. So synthesis gas is the product we want to craft, and therefore I put it into barrels and stack it up here. So this is now running, generating a lot of synthesis gas for us. Now the next stage of the process is actually, right, now I've showed you two ways of creating synthesis gas, but what do we use it for? Well, it has numerous applications. Let's have a look at it in the overview here. You can see this row. You can make the residual gas. This is what I've shown you. The residual gas becomes synthesis gas, also shown. Now these ones are the ones that can happen. So you can take the synthesis gas and make it into carbon monoxide and hydrogen. That's not a high value. Those are not high value products. So I recommend not using it for that. You can also do it the other way around, making carbon monoxide and hydrogen gas and combine it back into synthesis gas. I don't think that's particularly interesting either, because the carbon monoxide is actually requiring carbon and purified water. That seems a bit excessive to things to set up. And you can see carbon requires coke and carbon dioxide. So you can see it's quite a long process just to get synthesis gas in this way. Even though the only raw materials are actually carbon based on hydrogen, for that comes from water. Now the ones that are valuable is this one, the catalytic synthesis to methanol. This one is actually converting it back into naphtha. I don't think that's a good idea, but you can actually say, in the case of the previous example, now if we just go back up here, in here, last time I talked about these recipes. We had this original recipe which is more heavy on naphtha. This one is even more heavy on naphtha, and I said I didn't like this one. The reason I don't like this one is because it requires hydrogen and takes a lot of crude oil. Now the disadvantage of this one, which is using gas condensate, which is otherwise a waste product, is the disadvantage is that you get too much base mineral oil. However, if we look down here on the recipes, you can actually take the base mineral oil, as we're doing here, convert it back into synthesis gas, and if you really want to, you can take the synthesis gas and make it back into naphtha. And there we go. We've restored the same formula. We just use gas condensates instead of oil in the refinery. So that's definitely what I would recommend. If you're short on naphtha, it's better to take synthesis gas from all sorts of strange sources and bring it back instead of using the less efficient cracking. Where is it? I don't know where it is. It's that one. No, that one. No, somewhere. Where is it? That one. This one is not efficient, so don't use it. Now, okay, synthesis gas, and the last one I want to show you is this one. We'll come into that one. The synthesis gas catalytic methanation. That's a really tongue twister in my opinion. But anyway, let's have a glance over here. Here we have the input for this process is actually, let's start up the process, shove in some barrels of methanol, barrels of synthesis gas into this, and we have a pretty simple process. It requires some green metal catalyst. Can I slip through? Yes, I can. Green metal catalyst. I have synthesis gas, and I combine it with some carbon dioxide. Carbon dioxide is incredibly easy to make. I just put carbon into a liquefier, and then I get carbon dioxide out. It's interesting that it's a liquefier, because if you're just thinking about it, the easiest way to transform coal into carbon dioxide is just burning it. So what a liquefier does, I don't know that. In any case, we should also look at how we make these green metal catalysts, because they can be a bottleneck, and they can be something that's a bit annoying, because they require aluminium ore or bauxite, and they require silver. So that's a bit of a two medium rare ores, and they need to be crafted. They don't take a lot here. You take one of each, and then you get 10 catalysts. Each catalyst is used to generate 8 methanol. So it's not a huge draw on this, but keep it in mind, because over time, of course, as everything, it adds up, and you need to have an input of bauxite and silver in order to even start this process. In any case, this will generate methanol. Methanol is a very high value component that's used for a lot of things, and is on the steps towards plastic. So I'll keep it in mind. Methanol is extremely valuable, and a lot of things can be converted into, or anything that can be converted into methanol is good. And that's where we have out here. We have the two outputs. That's actually here. We get our barrels of methanol slowly accruing, and that's quite nice. We're also getting a bit of residual water out. Not a lot, but a bit, and we might as well. I mean, this is the case where is it really worth putting it in, because at this point you need to transform it back or transport it back somewhere else. In the case you're using robots, by all means definitely do this, but in a non-robot based campaign, I don't know, I don't think I would do that. Now the last recipe is, after all, the most complicated one. The input for this is water and synthesis gas. We take the synthesis gas out. Let's activate it. Here we go. It's now activated, and we take it into this one. Now we need a blue catalyst, and we'll come back to that. But this one takes the synthesis gas plus a bit of hydrogen gas, and then crafts. And this is where it gets really dicey. This is where a lot of people will break their neck in terms of Angel's mods. We get synthesis gas catalytic methanation, methane gas, ethane gas, and butane gas. And at first you're like, what the hell am I going to use these for? Because you're not really using them for very much. But let me go through that in one of the future episodes that will deal specifically with the organic chemistry change towards plastic. In this case, just know that this is the highest value output of synthesis gas. You can basically, if we look back, you can take your waste products, your oil residuals, your residual gas, your base mineral. Make sure that you don't take all the base mineral and convert it into lubricant. That is not a good use of it. You usually don't need a lot of lubricants, so be careful, unless you're making tons and tons of blue wells. In any case, this is a low value, especially the fuel oil is low value. So convert it into synthesis gas and convert it again, because plastic is always in short supply, and these are the steps towards plastic. Now let's look at the blue metal catalyst. There we have the blue metal catalyst. This is actually using something, the cobaltite and the rutile. That's the titanium ore. Those are very rare components. So this is an even more difficult and therefore also high level process. But once you have it up and running, it's just super efficient. Just have it crack away at the synthesis gas and make some very valuable. I mean, it's quite a compact one. One thing I should also mention is this one. You'll be using this quite a lot. Every time you need hydrogen or oxygen for whatever component. The way I always do it is I take some purified water, run it into an electrolyzer, and take out the stuff I don't need. And then in this case, I'd use the hydrogen, and all of the oxygen goes into this one, which is kind of a clarifier for gas. It just a flare stack, it burns it. So in this case, burning oxygen, yeah, fine. Now, so this is it may seem a bit difficult to set this up, but once you get it going, it's not really difficult. You just need some synthesis gas coming in, and I would also recommend doing it modularized like I'm doing now, because if you're ending up sort of like having oil residuals to residual gas to synthesis gas to this process, then what about where you get some other gases? So make it modularized, transport the synthesis gas over to a location that creates this, and then craft the hell out of it. You can expand it as far as you want. You can see there's not much draw on these two. So again, not very much. And in here, I basically just take these three components here. It's a bit annoying that it's so difficult to see the difference. So we have butane, we have ethane, and we have methane. And they will be, I'll dive into those, what we use for. But a teaser is those are some of the different paths to plastic, the various types of plastic. So there you have it. The residual gas, primary uses of residual is for synthesis. Anything of those materials you don't need, you can convert into synthesis gas, because then that's a high value product that can be used towards the plastic chains. Or methanol, which is also useful towards the plastic chains. So there we have it. This is the first step on the more advanced parts of the Angel's Petrochemical, but trust me, it gets more complicated from here. But that's why we're making these tutorials. So thank you very much for joining. I hope this has been helpful. You're free to leave a comment or a like, and I hope to see you in a future installment of this tutorial series. Thank you. Bye.